Hi, the purpose of this video is to try and instruct how to make Lewis structures. Now, a Lewis structure is a two-dimensional representation of a molecule, okay? And its purpose is to try and show how atoms fit together to form molecules, which atom is attached to which other atom. Now, the first step that you need to do is you need to understand how many valence electrons there are in a particular atom. All right. Now, for example, let's say that we wanted to draw the molecule for NH3. Okay. Now we got two elements here, nitrogen and hydrogen. And you start off by drawing each element. If you want to make the Lewis structure for a single element, you simply draw with the symbol in the middle, and then you draw dots around it. Each one represents a valence electron. And remember, you can tell how many valence electrons an element has by which tall column it's in. Remember, everything in column 1 on the periodic table has 1 valence electron. Column 2 has 2. You skip the transition elements, and then remember, this is only the main group elements. Everything in column 13 has 3, 14 has 4, all the way up to 18, which has 8. Now, since nitrogen is in column 15, it has 5 valence electrons. Therefore, we need to draw 5 dots around it. Now, when drawing the dots, remember, you put 1 dot in each of the 4 points of the compass, like north, south, east, and west, before you'd start doubling up. All right? Think about it this way. When you have an element, the valence electrons occupy 4 orbitals around that central element. Okay? And you have to put at least 1 electron in each orbital before you can start doubling up. So since nitrogen has 5 valence electrons, I'd put 1 in each of those 4 points. Notice I can't put any in the corners, so never put any in the corners. They only go in those 4 points. So nitrogen would have 1, 2, 3, 4. But since it has 5, then I can start doubling up. Now the next one can go in any location. All right, I could put the extra one here, or I could put it down here. It's just as valid. I could even put it over here, and it just doesn't matter. As long as you don't double them up until you have all 4 points around it filled with at least 1 electron. Now hydrogen has only 1 valence electron since it's in column 1. Okay, so around that we would only put 1 valence electron. And again, that can go on the sides, it can go on the top, bottom, doesn't really matter. Now, when drawing a molecule, you start with the element that can make the most number of bonds. All right? How do you know how many bonds an element can make? It's by the number of lone dots it has. This is known as its valence number, not the number of valence electrons, just its valence number. So here, nitrogen has 3 lone dots. Therefore, it has a valence of 3. It can make 3 bonds normally. Hydrogen can make 1 bond normally, since it has 1 lone dot. So, since nitrogen has 3 possible bonds, I'm going to start off with nitrogen in the middle. Now, according to this formula, there's 1 nitrogen, because you look at the subscript there, and you see that there's no subscript, which means there's only 1. Here, hydrogen has a subscript of 3, which means that it has 3 of them around it. And simple molecules basically have 1 in the middle that can make a lot of bonds, and all the other guys are usually attached onto it. So here I'm going to attach on, I have 3 hydrogens. Well, I'm going to put one of the hydrogens right here. And I'm going to line up its one dot so that it lines up with the lone dot next to the nitrogen. I'm going to do the same thing again down here. And since there's 3 hydrogens, I'm going to put one more up here. Now, these 2 dots represent the electrons that nitrogen and this hydrogen are sharing in a bond, okay, a covalent bond. And then to represent the bond, I simply connect the dots. And they have now a dash between them. I connect these, and this right here represents the Lewis structure for the molecule ammonia, NH3. It has nitrogen with 3 bonds attached to 3 separate hydrogens. All right? And that represents the simplest of the possibilities when you just have single bonds.